Hey guys! So today what we're going to focus on is being able to solve exponential and logarithmic equations. Now we're going to do it in a plethora of ways, but the focus is going to be in changing forms and being able to use what we learned on Monday to change from exponential to log and log to exponential and basically be able to isolate x through that, okay? So the essential question I want you to think about is that how do I tell which form to change to? If necessary. I guess I should throw in there if necessary. Because look at this first problem I have for you right here. Log base 3 of 9 equals x. Whoa, hit the pause. Is x already isolated? Yes. So then all you have to do is look at the left side and say, what is this number? Evaluate this right here. You guys know how to do this in your calculator. You just go, you hit math, you scroll up to log base, you type in the 3, you type in the 9, and you would get 2. So the reason I did this problem first is I wanted you to see that sometimes I don't need to change forms, okay? But there will be times that I do need to change forms, and our next example is a case for that. So here we have our next example. Log base x of 12 plus log base x of 18 equals 3. So you'll notice that both of these x's are trapped in a log, but that's convenient because it gives both of these logs the same base. That means that since I have two logs with the same base, I can make one log. Now, the logs were adding, so I'm going to keep my base x here. The logs were adding, but that means I can make one log and I make the 12 and the 18 multiply. And then it'd be very convenient for us to actually figure out what is 12 times 18. And we get 216. So what we have here is log base x of 216 is equal to 3. Okay, so now you might be going, but I don't know what to do from here. Well, we need to get x by itself. X is currently trapped as the base of this log. So then, by changing from log form to exponential form, so we do that by taking our base, that's x, raising it to the exponent, that's this 3 over here, is equal to the argument, that's 216. So now look at that. The log is gone. By changing forms, we were able to remove the log. Now the x is just trapped by the power of 3. How do I get rid of a power of 3? We've talked about this before in class. To get rid of a power, you raise it to the reciprocal of that power. So what is the reciprocal of 3? Just 1/3. So we just raise both sides to the 1/3 power. So we get x equals, so basically what this is saying is what number times itself is 216. It's like taking a square root, but rather than looking for 2, you look for 3. So 216 raised to the 1/3 power is 6. So x equals 6. That's my answer. Ta-da! Okay, let's do another example. Okay, so our next example, we have log of x equals -4. So in this situation, x is not in the base anymore, it's in the argument of the log. So now you have to ask yourself, okay, so what is the base? Well, hopefully you're like, Mr. No, that's easy, we've talked about it. The base is understood to be 10. But that x is still trapped by the log, so I need to remove the log. So to remove the log, I change forms. So I say base raised to my exponent equals my argument. Did I get x by itself here? I did. X is isolated. So now what I can do is just simply evaluate this number right here, which is just simply 0.0001. And I'm going to double verify that because sometimes I do mess up that kind of stuff, just like 10 to the -4th. But I do want to make sure that it is 0.0001. That was useless. It just means move the decimal 4 times to the left. 1, 2, 3, 4. So yes, I'm correct. 0.0001. So that is what x equals. Very good, very good. Okay, so let's work on another example now. So now we have the natural log of x divided by 2 equals 3. That means that the x divided by 2 is in the argument of the log, not in the base. Now this is natural log. So what is the understood base here? That's right, it's just e. But the x is still trapped by the natural log. So the first thing I need to do is get rid of the natural log by changing forms. So I say my base, so e, raised to my power out here, which is 3, is equal to x divided by 2. So now what I want to do is finish solving for x. I'm almost there, but what is the opposite of dividing by 2? Multiplying by 2. So I get 2e cubed equals, well, this divided by 2 and this times 2 cancel out, and I get x. So I get x is equal to 2e cubed. And I'm going to leave it like that. Now you may be wondering, Mr. Millen, why am I leaving e as e? I know it's a button I can type in my calculator. Well, do you guys remember how in geometry we used to ask you sometimes leave your, your circumference of a circle is like 2 pi or something? Or maybe it'd be 6 pi. We'd say leave your answers in terms of pi. Okay, that's the same idea. Just pi and e, though they're different numbers, have the same property of never ending. They keep going on forever. So I'm not going to actually replace e with a number. I'm just going to leave it as e. Okay? All right, let's do another example. Okay, so here's our next example. What we have here is log base 3 of 8x minus 13 minus log base 3 of 12x plus 21 equals negative 1. Okay, this is a doozy of a problem, but we're going to talk it through. Okay? First off, you have two logs with the same base, subtracting. So I can make that one log, and then I say, now I make the arguments, notice my base stays 3, and now I make the arguments divide. Okay? Now when we're done with writing this, you'll still notice we still have both the x's trapped by the log. So what I want to do is get rid of the log. I get rid of the log by changing forms. So I can say 3 raised to the exponent negative 1 is equal to the argument 8x minus 13 divided by 12x plus 21. That's a 12. Okay? Now, we're going to do some cool math here. What I mean by that is there are a lot of different approaches you could take here, but I'm going to show you something that should be fairly, that should make sense based on what we've been talking about in class. 3 to the negative 1. We can't have a negative exponent, right? So we drop that 3 to the negative 1 down, turning that negative exponent to a positive 1. And then I write my argument again. So 8x minus 13 divided by 12x plus 21. Now, this is very important. You notice this. I have a fraction equals, this only works when they equal each other. A fraction equals a fraction. So I can cross multiply. So I'm going to say 3 times 8x minus 13 is equal to 1 times 12x plus 21. So then I distribute the 3 in. So I get 24x minus 39 is equal to, distribute your 1 in, 12x, because 1 times 12x is 12x, plus 21, because 1 times 21 is 21. Now, what you got to do is get all your x's on the one side and all your numbers on the other. Well, I'm just going to subtract the 12x, subtract the 12x. So 24x minus 12x, I'm right up here, gives me 12x minus 39 equals 12x minus 12x cancels, so equals 21. Now what you're going to do is add the 39 over. And that's going to give you 60. So you're going to get 12x equals 60. Then you're going to divide by 12 on both sides. And you're going to get that x equals 5. Boom! There you go. Okay? Let's do another problem. Okay, looking at this problem, e raised to the 2x minus 1 is equal to 8. Alright, so first off, couple different things happening in this problem. This is an exponential problem. And the reason I know it's exponential is because x is in the exponent. So that means automatically I know when I see x in the exponent, I'm like, oh, that's exponential. To solve an exponential, you must change it to logarithmic. Okay? So, I'm going to write log. And then, what's my base right now to all this? E is my base. I'm going to write base E. Whoa, whoa, whoa. Do I ever write log base E? No. No, you don't. You write ln, representing the natural log. So the natural log of 8, you take your arguments over there, is equal to your exponent, which is 2x minus 1. Well, now this is an easy problem. I just need to finish solving for x. So I need to add 1. Do not say 9. This 1 cannot go inside the natural log of 8. This 8 is trapped by the natural log. It is like it's in jail. And the 1 cannot visit it. It has no visiting rights. So we just say plus 1 is equal to 2x. Then, alright, so this is 2x. What does that mean? That means 2 times x. What is the opposite of multiplication? Division. So both things need to get divided by the 2. So this gives me just x. And we are going to go figure out a number for this because it's not just, something simple like e squared like we had a second ago. So we need to type in So we're going to type in natural log of 8. Natural log is the button right here on the calculator. Divided by 2. Plus 0.5, because 1/2 is the same thing. That's 0.5. Press enter, and we get 1.5. So x is approximately 1.5. Good job. Okay, let's do another example. Okay, our final example is a doozy of an example. So what we have is we have log base 12 of x plus 4 plus log base 12 of x plus 5 equals 1. So we have two logs with x's inside both, but they have the same base, and the logs are adding. Which means I can make them one log, which is awesome. Having fewer logs is better. So log base 12. Now, when we're adding, what do the arguments do with one another? Hopefully you just said multiply, or thought multiply. So I'm going to show that. Okay. Oh, equals 1. Okay, so now what I'm going to do is I'm going to get myself out of log form. Okay, because I can't solve for x in log form. So I'm going to change to exponential form. So I'm going to say base raised to the exponent is equal to x plus 4 times x plus 5. Okay? Now, if this had equaled 0, we would have a really easy problem on our hands. It does not equal 0. Which means that in order to solve for x, what I first have to do is multiply these two things together. So first off, 12 to the first is just 12, is equal to x times x, which is x squared, x times 5, which is plus 5x, 4 times x, which is 4x, and 4 times 5, which is 20. So now I just undistributed this. I'm sorry, I just distributed these. I multiplied these two. Okay, so I unfactored them. When it was like this, guys, it was the factored form. But I just unfactored it. So I got x squared plus 9x plus 20. And the reason I had to unfactor is because factored form only helps me solve when I equal 0. The thing is, so factored form, this would have been great if it equaled 0. I could have just set each piece equal to 0. But I cannot do that with 12. Because remember, 0 is a powerful number. So instead, what I'm going to have to do is now subtract the 12. Alright, I get 0 is equal to x squared plus 9x plus 8. Now what I'm going to do is I'm going to factor this. Alright, because it equals 0, it's quadratic, so I know, oh, I can solve by factoring or by quadratic formula. I'm going to choose tic-tac-toe factoring. So I put my quadratic term in the top left. I put my constant term in the top middle. I multiply. So I got ax squared. I put my linear term out here to the side, and I ask myself two numbers that multiply to this but add to this. 8x and x, and 1x. X squared and 8x have what in common? X. X squared and 1x have what in common? X. X times what is 8x? 8. X times what is 1x? 1. Go across, go across. So, we get x plus 1 times x plus 8. And this is equaling 0 at the moment. So when we have a nice situation where it equals 0, and we have some parentheses multiplying, you can just set each parentheses equal to 0. So then we're going to solve. So I subtract 1, so x equals negative 1. Subtract 8, so x equals negative 8. Boom! So we have two answers. But wait, do we? Anytime that you get two answers, you should always check and say, do these both work, or is one of them extraneous? Okay? So let's talk about that. To talk about that, we need to go back to the idea of what is a log real fast. Remember that what a log does is it looks at the base, and it says this base raised to what number equals this argument. Okay? So that's what it does. It's trying to figure out the number that 12 would have to be raised to become this number right here. Alright? So basically, what you're trying to do is think, is there a number that I can raise 12 to? So let's plug in the negative 1. Let's plug in the negative 1. So 12 raised, so if I did that, I have log base 12 of negative 1 plus 4 plus log base 12 of negative 1 plus 5 equals 1. Okay, so now what you ask yourself is, okay, so what is negative 1 plus 4 really? Well, that's just 3. And what is negative 1 plus 5 really? That's just 4. So is there a number that I can raise 12 to? Well, let's actually now, let's stop making this hard. Check this on your calculator. Let me make this easy because this video is already dragging a line. If you were to check both of these in your calculator, you would see that it doesn't work for the negative 8. It works for the negative 1. But if you check this by hitting math, scrolling up to log base, typing all this in, hit plus, math, log base, typing all this in, and plugging in the negative 1 for both x's, and when you press enter, it's going to give you 1. But when you do that on the right, when you do it with the negative 8, it does not work. So this is an extraneous solution where this is your only correct solution. Alright guys, thanks for watching. I really do hope you guys have a great day. Feel free to ask me any questions. Feel free to send me an email. Alright, thanks.